This is the tutorial for Chapter 5, Section 3, and Chapter 5, Section 4 review, solving systems by elimination. We'll also see some special systems, and that's what we saw in Chapter 5, Section 4. So on the first one, a good one for solving with elimination, because whenever x's, y's, equal signs, and constants are lined up, elimination makes a lot of sense. So what I'm going to end up doing here is multiplying this top equation by some number so I can either cancel out the y's or the x's. See, if I just multiply this by a -2, every single number up on that top equation by -2, it becomes -4x plus 2y equals 0. And you see, the reason for doing that is so that when I add the two equations together, I can get the y's to cancel, so I'm just left with x. And I have -x equals -3. So when I go ahead and divide by -1 to cancel out that coefficient in front of x is 3. So from there, that makes it a lot faster. Now I still have to substitute, though. So I'm going to take that x value, substitute it in for one of these x's here, and solve for y. So 2 times 3 minus y is 0, so this makes 6. 6 minus y is 0, so all I have to do is just move the y over, add y to both sides, and I'll figure out what y is. So 6 is what y is, and I just write that as an ordered pair, 3, 6. So on this next one, I'll do the same sort of thing. I'll multiply the top equation this time by -3, because I saw that I could cancel out the x's if I could just make this a -3x. And that's what I can do by multiplying the top equation by -3. So -3x minus 12y equals -3. That's what we have when we modify it by multiplying every number there by -3. When I bring down that bottom equation, 3x plus 5y equals 10, add the two equations together, the x's cancel, so I'm left with a -7y equals 7. So when I do that division, y is -1. I take -1, substitute it back in for one of these y's. I'll probably pick the top equation before I modified it. And I multiply 4 by -1, and that gives me -4. And then all I have to do is just add that 4 to both sides, and you get your answer. So x is 5. So my answer is 5, -1. So let's take a look at some other types. This is from Chapter 5, Section 4. And what you'll notice here is the x's, y's, and equal signs and constants are on line. So it makes a lot of sense to use elimination. But I got to get them to be opposite in sign so that when I add them, I'll get the x's or y's to cancel. So I'm going to multiply that top equation by -1. Now watch what happens. All the signs switch. And so when I go ahead and add these together, the 2x and the -2x make 0. The 3y and the -3y make 0. And I end up getting +2 when I add 7 and -5. So I'm left with 0 equals 2. So when you do this, and everything cancels, your x's and y's both cancel out, because that didn't happen before. If you look at the other problems, you see when we went ahead and tried to cancel something, we were left with an x. Here we were left with a y. Well, over on these, everything cancels, and so what we have here is no solution. So what this means is that the lines were parallel. We had parallel lines. And remember, when we're trying to solve a system, we're looking for where the lines cross. And so in this case, the lines look something like, let's say we have a 5 and a -3, so it would end up being a negative slope. So the lines look something like this, where they're just never going to touch. And over here, on these other problems, you see they do. They do. This one, they cross at 3, 6. That's what that point is of intersection. But on these problems, they do not cross because they're parallel lines. So there's no solution. Lines are parallel in this case. On this next problem, it's a good substitution problem because we have y by itself. So I'm going to take that expression that y is and substitute it in the top equation. So I'm left with x plus 2 times by -1/2 x plus 6. And I set this equal to 12. And so when I go ahead and distribute, I've got x plus, and actually I'm going to put a minus because 2 times -1/2 makes -1x, and I've got a +12, and this all equals 12. Well, these two terms cancel out. They make 0, and I'm just left with 12. And when I go ahead and see, I've got two numbers that now equal. This is called an identity. And so when we have an identity and we're solving a system, that means that we have the same line. So there's infinitely many solutions because we have the same line. These are exactly the same line. If I went ahead and solved this for y, we'd get the same equation. So same line. There's infinitely many solutions is what we end up seeing there. So let's take a look at the next type of problem that we'll end up seeing. And it's a problem in which we have to solve this system. So we go ahead and read on, and it says that the table shows the number of correct answers on the practice standardized test. You score 86 points. Your friend scores 76 points. And you're supposed to write a system of linear equations to represent the situation. And so here's what we really need. How many points in each type of question is worth? So we need to figure out what the question is before we can figure out what our variable is. Because whatever the question is what our variable is. So let's call m equals the number of points per multiple choice question. And let's say that maybe r equals the points per short response. And so what we want to do from this point is write the equation. Now when we do that, we see how multiple choice, the points is m, and you scored 23. So we're going to write this as 23m plus, and then your response for that was 10. So we had 10r, and this all equals, you scored 86 points is what it showed. And then on the other one, we had 28m, that's what your friend had, plus 5r equals 76. So we're ready to go ahead and solve. I'm going to go ahead and multiply this bottom equation by -2, every number there. And so here I'm left with a 56, negative 56m, and then plus minus 10r equals, and then I go ahead and multiply this out, and I've got 12, and then this makes 152, and that's negative. And then over here, I'll just bring this equation down. I'm left with 23m plus 10r equals 86. So when I go ahead and add these together, I end up getting a 33m, and over on this side, it looks like I'm going to end up getting 66. That's negative. Both of them are negative. So when you do the division, you end up canceling out the negative 33, the negative signs and all, and it looks like m is 2. So we've got 2 points. 2 points is what the short response, or the multiple choice, is worth. 2 points per multiple choice. Multiple choice, I'll just put MC for now. And now we want to find out what the free response is worth. So we just substitute that 2 back into one of these equations. And I'll just put it into this equation right here. So I had 28 times by 2, and then plus 5r equals 76. So this ends up giving me 56 plus 5r equals 76. So subtracting the 56 from both sides gives me 5r equals 20. So it looks like a short response is worth 4 points per short response. Alright, so that's the number of points, how many points each type of question is worth. Let's move on to one other problem here, and it says that you can jog around the block twice and around the park once in 10 minutes. You can jog around the block twice and the park 3 times in 22 minutes. Write a system of equations and ask how long does it take you to jog around the park. And so let's write down that maybe P equals the time to jog around park. And then I'll go ahead and define around the block, we'll go with B. So time to jog around block. So from this point, I'll set up my 2 equations. My first equation said that I can go around the block twice. So 2b in the park once, so plus 1p, and that equaled 10 minutes. 10 minutes is what it said right there. So the next equation says you can jog around the block twice, so 2b again, But this time the park 3 times, so 3p, and that took 22 minutes, it says right here. So it's a great elimination problem. I could just multiply by -1. This will cancel out the b's. So I'm left with -2b minus 1p equals -10. So when I go ahead and add this together, I get 2p equals 12. And so it looks like when I do that division, p equals 6. So 6 minutes to go around the park. And that's all they needed in this problem, because it just says how long does it take you to jog around the park. So those are the types of problems you'll see on tonight's homework. Good luck.